Bright QT. Every student matters.
Hello everyone. So we'll continue our chapter square and square roots. What we are going to discuss now, we are going to express, or we are going to get some more properties. We're going to express the squares in much simpler form because finding squares of larger numbers is a bit difficult, and then we are going to observe some other patterns. So just to see here has the first concept for today, that is finding the square of a number. Finding the square of 3, it is easy. We can just write 3 into 3 and we know it would be 9. Finding square of 4 is 4 cross 4, that is 16. Similarly, finding square of 5 gives us 5 into 5, that is 25. Right, so this is how we can find the square if the numbers are smaller. What if we have to calculate 23 square? Is it easy for us to just write directly 23 into 23? We need to multiply 23 and 23. Actually, we need to multiply. It's not that easy that we write the answer directly as we were writing for smaller numbers 3, 4, 5, 10, 11 like that. But if we have to find out of 39 or 52, if we have to find out the squares, it becomes difficult for us to write the answers directly. So what we need to do is we need to definitely have to multiply 23 with 23, and it will take time. So is there any other way that you can think around? Yes, there is one way that we can do. 23 can be written as 20 plus 3. Right, 20 plus 3 whole square. We know a plus b whole square is equal to, let us calculate it. It will be a plus b multiplied with a plus b. Now a will get multiplied with this bracket, right, and then b will get multiplied with this bracket. So we get a into a is a square plus ab plus ba plus b square. So we have a square plus ab and ba are same thing, so it is 2ab plus b square. See, this is the formula for a plus b whole square. So whenever we have to multiply two brackets and they have the same numbers inside the bracket with the same operation, so we can just operate them a square plus b square plus 2ab. So here also we can apply the same identity. It is 20 plus 3 multiplied with 20 plus 3. Why we are converting 23 to 20 plus 3? Because to find out the square of 20 it is easy. To find out the square of 3 it is really easy. Okay, so what we will do, we can directly apply the formula. It is a square. A is here 20, right, and what is b here? It is 3. So a square, that is 20 square, plus 2 into a is 20, b is 3, plus b square is square of 3. So we get 20 square is how much? 400, plus 2 into 20 is 40, 40 into 3 is 120, plus 3 square is 9. So you see, 400 plus 120 is 520 plus 9, and it gives us 529. So yes, the number of steps are increased, but the calculation and the solving time is definitely minimized. What we have done, we have calculated the square of 23 not by multiplying 23 with 23, but by writing 23 as 20 plus 3 whole square, and then applying the identity a plus b whole square, that gives us a square plus b square plus 2ab. We used it in this one and we have got the answer as 521. Yes, steps here are increased, but these are really easy to solve and they take very less time. Okay, let's practice some more example. Just see here, they're asking find the square of the following numbers without actual multiplication. That means if I have to find the square of 39, I don't have to multiply 39 with 39. Without operating this, without actually doing the multiplication, we have to solve it. So to simplify our calculation and without doing the actual calculation, actual multiplication, what we will do, 39 can be written as 30 plus 9 whole square. Right, it can be written as 30 square plus 9 square plus 2 multiplied with 30 multiplied with 9. Why are we doing this? Because we know a plus b whole square is a square plus b square plus 2ab. We have just got this in the previous slide. If you see, we calculated is a plus b multiplied with a plus b gives us a square plus b square plus 2ab, right? So whenever we have to multiply the like this, we can directly apply the identity. So here also we have applied a square, b square and 2ab. 30 square is 900 plus 9 square is 81, we know that, plus 2 into 30, right, that is 60. 60 into 9 is 540. Clear? So now 981 is 981 plus 540. Let us add them. 981 plus 540, we get 1. 8 and 4 is 12. 1 is the carry here. Then 9 and 1 10 and 5 15. So what is the answer that we are getting? 1521. So this is the square of 39. Is that clear to you? What we have done? Express the 39 as 30 plus 9. Also, we could do it in a much simpler way. We could have written 39 as 40 minus 1 whole square. And then we have done 40 minus 1. Then we have done 40 minus 1 into 40 minus 1. We would have multiplied and solve it easily, right? Because we know square of 40 is easy, square of 1 is easy for us. Let us do for 42 now. Let's now do for 42. So for 42, how can we write to find out the square? Without actual multiplication, we have to do it. So 42 square can be written as 40 plus 2 whole square, right? So we will multiply 40 plus 2 with itself. We get 40 square plus 2 square plus 2 into 40 into 2. So 40 square is 1600 plus 2 square is 4 plus, just see, 2 into 2 is 4. 4 into 40 is 160. Clear? Let's add them. 1600 plus 160 plus 4 is 164. In 1600 we are going to add 164. We get 1764. So this is the square of 42. So without doing higher, complex calculation, without multiplying 42 with 42, we are getting the answer, and that is really simple. For these we don't need calculators, we don't have to do it manually. Just by looking on the number we can tell what will be the answer for that. So these calculations are very easy, much easier than multiplying 42 with 42. Is that clear? Let's move ahead now. So the next topic is other patterns in squares. So there is one more pattern that we can see and observe and apply to the questions. So whenever we have to find the square of a number whose ones digit, or I say unit digit, is 5. So suppose the number is a5 in general form. This a can be 1, this a can be 2, this can be 3, it can be any number. This can be 11, okay, this can be 12, like this. So this can be any number. So whenever we have to find the square of such numbers, that means a5 whole square. See, 15 can be written as 10 into 1 plus 5, right? 25 can be written as 10 into 2 plus 5. 35 can be written as 10 into 3 plus 5, right? 115 can be written as 10 multiplied with 11 plus 5. 125 can be written as 10 into 12 plus 5. So see, 10 is same in all, 5 is same in all. What is this? This is the numbers, or I say the digits, except the digit 5. So except 5 we have 1 here. So we multiply 10 with 1. Leaving 5 we have 2 here, multiply 10 with 2. Leaving 5 we have 3 here, 10 multiplied with 3. Leaving 5 we have 11 here, 10 is multiplied with 11. And 5, except 5 we have 12, so 12 is multiplied. So every time, how can we express a digit or a number that has the unit digit as 5? We can express the number as 10 multiplied with the front number, we are naming it as a because it is variable, it can be any number, plus 5. We can write like this. A5 can be written as 10 multiplied with A is C, these numbers only, plus 5, its whole square, because here we have square. Clear? So A5 can be written as 10 multiplied with A plus 5 whole square. So we are going to first solve this. Just to see. 10A plus 5 whole square is 10A plus 5 multiplied with 10A plus 5. Square of any number means the number multiplied with itself. So here we have done the same thing. Now first 10A will get multiplied with this bracket. So 10A plus 5, then plus 5 will get multiplied with this. So 5 into 10A plus 5. Okay, just see, 10 into 10A is 100 A square. A into A will form A square. 10 into 10 is forming 10 square, that is 100. Plus 10A into 5 will be 50A. Plus 5 into 10A is 50A. Plus 5 into 5 is 25. So we get 100A square plus 50A plus 50A is 100A plus 25. Okay, now in these two, what is common? 100 is common, A is common. We can write A plus 1 plus 25. So what we observe is, if there is any number that has the form A5, A can be any number, okay, it can be 1, 2, 3, 4, 5, 11, 15, 12, any number. So when we do the square of it, we just have to do it A into A plus 1 into 100 plus 25. So this formula is always going to help us. Here A is the number that is written in except 5. A is what? The number except 5. Clear? Or the digits except 5. So if I have to find square of 15, what will I do? A is here 1. So 1 into 1 plus 2 into 100 plus 25. So 1 into 1 plus 2 is 1 plus 2 is 3. Wait, we have 1 plus 2. Okay, so we had to do A plus 1. A is 1 and plus 1 we have to do. So we get 1 into 2 into 100 and then we have plus 25. So we get 200 plus 25, that gives us 225. So square of 15 is 225.